This week in Calc 3, we are going to discuss Greens Theorem. Very, very powerful theorem in multivariable calculus. And it happens to tie in nicely with our study of dimensions. So again, remember this course, we're kind of starting and working up by dimension. We started with vector fields as just kind of a preliminary base, and then we worked in one dimension with line integrals and vector line integrals, and now we're just wrapping up the study of double integrals and iterated integrals. And so Green's theorem kind of ties in that idea of line integrals and double integrals quite nicely. Okay, and as you can see here, the theorem stated on the page. So highlights. We have to make sure that D, our region, is closed and bounded on R2, and that if we're looking at the boundary, so that's a partial, meaning the boundary of C, that consists of finitely many simple, closed, piecewise curves, and then we have to orient C so that our region D is on the left as we traverse traverse that boundary. Okay, and so we have a vector field, okay, C1, fine, and then what we say is that the closed integral, so around the boundary for that vector line integral is the same as the double integral. Okay, very, very nice, and it's going to make our life easier eventually. But right now, just as a follow-up for the conditions, we're wondering which of these satisfy the assumptions of Green's theorem. So pause the video and take a shot at these. Okay, well, I think if you had a moment to pause the video and double check these and the assumptions. So the first one, we kind of have to go around, okay, is it closed, is it bounded? Yep. And what else was there? Is it simple? Yep. And the curves are closed and piecewise continuous. Okay, fine. And then as we kind of walk around on this given orientation, is the boundary on the left? Yep, so this is going to work. This other one, if we look at this, okay, is it closed, bounded? Yep, piecewise continuous curves. Well, there's one, okay, fine. But if we look at the orientation, as we go around here, the region D is actually on our right side, so that's not going to work. Okay, oops. So this is no, we go in the wrong direction. Okay, and the next one, closed and bounded region, yep, and boundary consists of finitely many simple, oops, nope, okay, so no, not simple. Okay, and so that's just going to wrap up this video, and then in the later videos, now that we've kind of worked with those assumptions a little bit, we'll actually see the conclusion in action.